Hello everyone, this is Wilson. Let's talk about this limit problem here. We have this function x squared minus x and over 1 minus the square root of x. And x is approaching 1, so as you can see here, it's quite obvious that when we plug in a 1, we are going to get 0 over 0 in determinate form. So from there, we cannot draw any conclusion. So we got to find some way to evaluate this limit. And for this limit problem here, for this function here, we have a radical, a square root in the function. And when it involves a radical, we got to try a different technique of dealing with this limit. And actually, we can still use factoring to do it, but then that's more difficult to factor this kind of limit problem. So there was we can try to use a different way to do it to make it easier. Yeah. Okay. So let's do that. I'm still just going to show the direct substitution really quickly, just to show that when you substitute the 1 into the function, it's going to approach 0 over 0. So as you can see here, that's 1 squared minus 1, that's 0. 1 minus square root of 1, that's also 0. So that's, yeah, so we got to do something to this function. Okay, so we are going to get started now. What we can do is that at the beginning we can see what we can do right now for the numerator. We can actually factor the greatest common factor, which is an x. And so if we factor that, then we are going to get x, and then we get x minus 1. And then in the denominator, we are going to be getting what do we get here? If we are trying to factor it over the set of real numbers, we can, but we are not going to do that here. Okay. What can we do here? We can do something like this. We can multiply the numerator and the denominator by the conjugate of this expression here, 1 minus square root of x. Its conjugate is actually just changing the sign in the middle, so that would be 1 plus square root of x. Okay, so if we do that, then we are going to multiply the denominator by its conjugate, 1 plus square root of x. And that's actually changing the problem. So what we need to do right now is to do the same thing in the numerator so that we are multiplying by 1. So make sure that we don't change the problem. So we got to multiply the numerator and the denominator by the expression. Okay, so actually let's try to clean up the whole expression, put everything together into a single fraction and see what we have. So in the numerator, we are getting x times x minus 1, and then times that factor, which is 1 plus the square root of x. And then now for the denominator, and you can see that we are multiplying 1 minus radical x by its conjugate. And so let's just recall something right here. Recall that when you multiply an expression by its conjugate, then do you see what's going on here? We are actually getting the difference of two squares. So you square the first term, and then you square the second term, and then you are going to take their difference. So you subtract them. And we are actually going to get the same thing here. So we are going to square the first term, because the first term, as you can see here, that's just a. What about the second term? The second term is it's the b, right, which is square root of x. And so square root of x is the b, or the b is the square root of x. And so if you square the first term, which is the 1, if you square that, you're going to get the 1. Okay, so you get 1 minus. Now, if you square the b, which is the second term, you are squaring the square root of x, you are just going to get x. So see that that's nice. There are no more radical at the bottom. This is actually the technique that we usually use to rationalize the denominator. But we are just doing it here to turn the denominator into a factor, into an expression without the square root. And you can actually see that the good thing had already happened right here. You can see that there was in the numerator there was the x minus 1, in the denominator there was a 1 minus x, and you can see that there's a little we just did something that's really um, trivial, that we can actually start canceling them. What we need to do right now is to factor out negative 1, right, from either the numerator or the denominator, doesn't matter which one. Okay, so if we do that, then we are going to get this. So if we factor out negative from the numerator, then we are going to be getting negative x. Okay, so let me just highlight the sign right here. Yeah, so we are going to get negative x here. And then this factor right here will change into its opposite. So the negative 1 becomes positive 1. And then the positive x will become negative x. So we get a minus dx. Okay. And then we still don't change that, the other factor, which is 1 plus the square root of x. Okay, so what about the denominator? We don't do anything. We just copy. And so now you can see that we do have the 1 minus x, and those are the two factors that are causing the indeterminate form, right? Because we plug in the 1 in there, that's 0, right? So they're both approaching 0, and then we can now actually just cancel them. So we cancel them right here, and then we do not really have a fraction anymore. So if we cancel them, then we are going to be getting, what do we have here? The blue negative sign, right? The blue negative sign, and then there was the x in there. And then there is also the red expression, which is the 1 plus square root of x. And then that's all we have left. And what we can do right now is to just plug in the 1. We can do a direct substitution. So we get minus, and then 1 plus the square root. And then now all the x's will be replaced by 1, right? Because we're substituting the 1. We're doing a direct substitution right now. And then what happens? We have negative 1, and then there was a 1 plus 1, right? So we actually are getting negative 1 times, what is that? That's 2. So we are getting negative 2 as the final answer. Okay, so that's a simple problem. Yeah, so the technique, the strategy for dealing with this kind of limit problem when its form is 0 over 0, it's that we can actually multiply by the conjugate of the expression that involves the square root. Okay, so when it has a square root, then you can multiply by its conjugate so that you can cancel out that radical, and then there will the factor that you can cancel out will show up, and then when they show up, then you can actually start canceling them. But sometimes you also need to do a little bit of factoring. But what I want to say is that we can actually, without doing this, without multiplying the top and the bottom by the conjugate, we can actually do this. We can factor the x minus 1 into square root of x plus 1 and square root of x minus 1. In that case, we are still using this formula right here. And so if we factor that, then it will give us a factor that can be canceled with this 1 minus radical. But doing it that way is not as straightforward as just doing the multiplication of the conjugate. So that's why I chose this method to do it here. Okay, so that's it for this problem. If you like my video, please subscribe my channel. Please leave me a comment, give me a like, and then also please share my videos. And then it's also good to check out my other videos on this channel. Thank you for watching this video. I will see you next time.